Seasteading. How do we build cities at sea? Hello everybody, I am Nick the Naval Architect. Seasteading. How do we build a city at sea? I see this question cycle back into popular interest every few years. It's usually championed by some visionary person, someone with a bold new dream and not enough money to achieve it. But we rarely ask the engineer. It's my job as an engineer to take those dreams that people bring me and mold them and forge them into reality. So speaking as a forger of dreams, what do I think of seasteading? Is it actually possible? Well, first off, we need to clarify what we mean by seasteading. Placing some houses on stilts that are only 2 meters from the shore? No. That is not seasteading. Number one, we're going to create a permanent community of people that live offshore. That community does have to be self-supporting and sustainable. Now that doesn't mean completely self-contained. They can trade with other people for needed supplies, but they need to be able to provide some sort of equivalent value to maintain that trade. Now we talk about service life. Most ships are designed to be scrapped after 30 to 50 years. Seasteading, we want it to have pretty much an indefinite service life. This city needs to go on forever. And what about the location? A true offshore city, we're looking at somewhere around 12 to 200 nautical miles from land. And then the last criteria is economically viable. And this is the one I really want to emphasize here. Economically viable. This is what kills most of the dreams. Most of the time, engineers can find a way to make something work if you're willing to throw ungodly amounts of money at the problem. But that isn't how the world usually works. And that is not the challenge that we're facing with seasteading. We shouldn't be asking, is this possible? Can we build a city at sea? Because the answer is, from a technical and scientific standpoint, yes. But that's not the question. What we need to be asking is, can we make this profitable? Can we make it worth the effort to build cities at sea? Well, the first place to look is history. So let's start by surveying current technology. What already exists for offshore living? And this is where we find that most of the previous ventures were successful because they were willing to push ungodly amounts of money into the venture. So let's look at these historical examples to see both the technology that they used, but also what were the economic conditions that made it work. And the first one that we have up is the research vessel Flip. The RV Flip was specifically designed to be a floating research platform that minimized the motions from ocean waves. You tow it out, it flips itself vertical, and sits there on a very, very tall column with a small area at the waterline. We see the first critical technology for seasteading. We need some way to minimize or protect ourselves from ocean waves. Okay, so how did the RV Flip manage to justify itself economically? Well, it was originally built by the US Navy. So we're working with the defense budget. That is already a pretty unique economic condition. So let's just say the RV Flip was a once-in-a-lifetime option. We can't really use that as an economic basis for the future. The next example we have is a cruise ship. And you might think that the cruise ship is a perfect example. Let's just build lots of cruise ships and there we go, we have seasteading. Not so much though. A cruise ship is organized around a very, very dense population. And people are paying a premium for the experience, not so much for just the fact that they're living there. The cruise ship is again a unique scenario because it's not really sustainable to expect people to pay for that level of service long term. Or if they are, they're bringing in income from outside the seasteading. And remember, we said that it had to be economically sustainable. So that type of highly organized structure with a very dense population, that's not really going to work for a seasteading environment in the long term. Then the final example we have is an offshore accommodation barge. You see this in the oil and gas industry, where we might have a cluster of several oil rigs all in one site. That is going to require a large staff. And so sometimes what they will do is bring in an offshore accommodation vessel. This is another vessel that floats next to the oil rig, and it's basically a floating hotel. And it does show us another solution to how to deal with the waves, because their strategy is to build the platform very, very high above the waves. That avoids the whole problem of wave interaction. But I can also tell you that's pretty expensive to build what is essentially a treehouse on water. And then we come to the question of where does this vessel get all of its power from? And in this case, they're sitting on top of an oil well. So normally they will use generators specially designed to run off of the extracted natural gas. That's a great example here for seasteading, is we want to be able to use the resources that are on site for most of our energy needs. Again, is that accommodation vessel self-sustaining? No. The only reason it's there is because of the nearby oil well that's extracting all of that beautiful black gold. That resource extraction is what justifies the expense of the accommodation vessel. So again, we see this is a case that is not self-sustaining. In all of these, we've seen several pieces of technology that we need to apply to create a seastead, but we still haven't solved that problem of how do you create an economically viable base. And this is where we really start to look at the population density. Most designs try to pack as many people as possible into a structure to maximize the revenue that's coming in. But I would argue that's not the way to go for seasteading. See, the more density you have for people, the higher the risk. And from an engineering standpoint, we still need to protect the people. Take, for example, a cruise ship with the freedom of the seas as our prime example. That has only 36 square meters per person. It's actually not that much space. And to produce that capability, we have very advanced firefighting systems, a constant staff monitoring everything that are highly trained. We have lots of equipment and drills. It's an incredibly contrived and very highly maintained environment. That's not going to be an easy approach for a self-sustaining seastead. So I would argue that for seasteading, we actually need to target a low population density. Most people don't realize that just building physical space, the structure of a ship, is not nearly as expensive as all of the machinery that goes into that ship. So building physical space is not as bad. And having a large physical space can help to alleviate a lot of our safety concerns. If we have that low population density, that solves a lot of our problems for, say, fire protection and flooding. Because in an emergency, we would be able to very quickly evacuate people to a nearby structure. And because of our low density in our population, that structure has the spare room to take on extra people in an emergency. That's not true for something high population density like a cruise ship. And so the low population density actually becomes a cheap way of having personnel safety. All of that's pointing to something that's not really like a cruise ship. Instead, picture something closer to a massive raft of dozens or even hundreds of barges out at sea. And speaking of those low numbers, have you seen this? Do you realize that less than 1/6% of the people who watch this channel are subscribed? Can you believe that? My kittens sure can't. They are convinced that without subscribers, they will lose their kibble. You can see they are just wasting away without their subscribers. So please, subscribe. Do it for the kittens. They're so worried. They need you. Back to seasteading. I've talked a lot about the problems and the general challenges that we're going to face for seasteading. Well, what about the solutions? And to be honest, I don't have all of the answers of how can we make seasteading economically viable. But I can at least talk to the technology. What type of technology do we have that we can apply towards seasteading? And the first is to answer the question of service at sea. No matter how much you build your ship, nothing is going to last for 100 or even 1,000 years. Eventually, we have to do maintenance, we have to replace sections of the hull, and you can normally do that a little bit at a time, but ships go into dry dock to do that. So instead, we're going to have to do service at sea. How do we do that? The answer is a cofferdam. Think of it as a bolt-on temporary submarine, essentially, and it creates the ability to work on pieces of your seastead at sea and do those replacements. Now, this would be quite a challenge to have a cofferdam that would be safe in the open ocean environment. So most likely, we're going to have to start at day one designing both the seasteading hull and the cofferdam to go with it. Now, talking about that self-supporting capability. From the technology perspective, to be self-supporting, I think we're using floating structures. We don't want to build a seastead on trusses or giant supports that are coming all the way up from the seabed. If we're 200 nautical miles out, the seabed is really far down, and that would just be too expensive. So we're totally talking about floating structures here. We've already mentioned the low population density, but to me that also talks about distributed population and distributed infrastructure. Compare that to a cruise ship, where all of the sewage feeds into one central sewage processing plant. That means if that plant goes down, everybody is in trouble now. But let's look at a distributed infrastructure case instead. There are 10,000 yachts in the world roughly. That's supporting around 40 to 80,000 people already living at sea. And each one of those yachts has their own sewage system, their own fresh water system, their own power. That's what I mean by distributed infrastructure. Because if we have one piece go down, that limits how much it can impact the rest of the population. So having that distribution and making each section of the seastead fully independent is going to give us a lot of redundancy and a lot of resilience. The next thing we're going to need is modular design. I know in your head you might be imagining this grand, custom-designed offshore structure. The problem is, custom design is really expensive. If we're doing that every single time, nobody's going to afford a seastead. Instead, we need a modular design, something like the Model T or the Liberty ships, something where it's designed once and then we pump it out by the hundreds or even thousands. Picture in your head a barge with a square block on it. That's more what we're aiming for. It's probably unremarkable, not very inspiring, but it's cheap and easy to build. And then we come back to the issue of waves. We saw several solutions with the RV flip and the offshore accommodation to see how they handled waves, which was basically to make the structure insensitive or in some way immune to wave action. But those are very expensive solutions. So instead, we're probably going to be looking at the cheaper option, which is to try to build a floating atoll at sea. To do that, we're going to need to create a protected harbor using a breakwater. Now, that's one of those key technologies that doesn't quite exist yet for the offshore section, but we're going to have to figure out how to cheaply build an offshore breakwater so that we can have a section of relatively calm seas within the larger ocean. And that'll allow us to then build simple barges that we float inside those relatively calm seas. And that technology is so important that I'm going to have a whole separate video about breakwaters. Now let's talk about the issue of self-supporting. What does that really mean to be self-supporting from a technical perspective? I'm not talking economics just yet, but technically speaking. Well, first off, energy. We're going to look heavily at renewable sources of energy, sources that we can extract from any site, wind and wave energy. Wind is a very mature technology. We've even got offshore wind turbines now, and they're quite massive. One or two of those could probably power the entire seastead. There are also several wave energy devices as fledgling technologies, so wind and wave will be primary sources of energy most likely. They will probably need some form of buffer, some way to temporarily store energy for those days when winds and waves are not blowing hard. Now you might have noticed I didn't include solar in that list. Maybe we'll use solar, but if we're trying to power an entire city, it's going to take a lot of solar panels that we most likely have to protect from ocean waves, making our atoll and our breakwater even larger. So that might not be economically viable. We've got to think about how can we keep our overall area small while still focusing on the low enough population density to keep safety. we're going to be looking at food sources that use the existing water. So we're looking at aquaculture. We might very well have hydroponics on board. Those are much denser crops that can be devoted to a small section on the existing barges. But again, all of those are going to depend on having a protected harbor. So there's definitely going to be a trade-off here. How much space do we need for our food production, and how expensive is that going to be for creating the protected harbor? So I haven't given you all the answers, and that's because I don't have all of them. This is still an area that requires a lot of active research to solve the problems. And right now we're just trying to define those problems to understand where do we need to develop further. So, looking at today, is seasteading viable? Remember how I asked the question initially. It's not a question, is it possible? It's a question, can we make it cheap enough? I would say probably not. Not right now. And I don't think we're going to jump to immediately putting cities offshore. Instead, I see a progression. First, we would probably start with creating nearshore apartment blocks. Residential living only for those crowded coastal cities. That's the first step. Step number 2 is we're then going to be looking at offshore energy. That's us building the technology to extract energy from the local area. And you'll notice we're already doing that. We have offshore wind farms. So we've already got steps 1 and 2 pretty well done. Step 3 is going to be the next challenge. Coastal atolls. We're trying to create artificial harbors here. And remember, the question is always, can I make this viable? Can I create a coastal atoll that is justified economically? Something where, again, we're probably still pulling resources like energy and food from the local surrounding land, but we've done something now to justify this artificial structure offshore. And I think the first real case is going to be offshore marinas for yachts. I know here where I live in the Great Lakes, there are very few slips available for marinas now. There's a lot of boaters that are on waiting lists that are years long. And the whole problem is that there's no coastline left. All of the areas that could be developed for marinas have been. That's the kind of demand that's going to spur us into step 3. These little marinas that are just off the shore, but they're still within protected lakes or other protected regions. Once we've figured out how to create a coastal harbor where we still have a lot of near land support, then we're going to eventually go to full offshore seasteading, where we're taking all of these individual technologies that we've learned, and more importantly, the lessons we've learned of what kind of economics will make this justifiable. And that's when we're going to go to full offshore seasteading, taking all of these technologies and putting it out in the open ocean. The 2 things we'll need, economically speaking, is you'll have to get more expensive to live on land, which is going to happen through increased scarcity, and then we'll have to have found that technology really allows remote jobs to be a very viable economy. With that, then we'll see full offshore cities. So let's summarize this all up. Like I said before, the biggest barrier is not technology. It's not a question of is it possible? Is it affordable? Can we make this profitable? Economics are going to drive seasteading. And I think one of the critical elements for that is that land is going to have to become more expensive. It is a real investment of energy and cost and effort to build structures offshore. And right now, land is still cheaper than offshore. So we're definitely going to have to see an increased demand and scarcity that will change that equation. Once that actually happens, once we have a demand, the question is, how do we progress from just a dream to an actual offshore city? And I think the strategy there is going to be, number 1, avoid large infrastructure. Don't build these grandiose dreams that require billions and billions of dollars in investment. No. Start with low-cost, small, modular units, something that a community of 50 or so people can get together and afford. And design it so that those communities can grow organically, that you can start with just one module, and then another 50 people join next to that module, and then it grows and grows and grows until we have thousands and thousands of people in this mass-produced modules of cities that are spread out. That's how the seasteading is really going to grow. Start, think small, grow big. And then we come to the final technical hurdle. The question that everyone wants to know is, if we can make this work, if we can find the justification, is it actually possible? Can we build cities at sea? Maybe. We don't quite have the technology now. We need some near future technology, but we can definitely see the path for how research could create the answers and the technology that we need to eventually see full cities at sea. Thank you very much. I am Nick the Naval Architect. And if you like this channel, tell a friend about it.
I am Nick the Naval Architect.
You know, it's like when they say I am Groot, only all we can say is I am Nick. So are you wondering where all of the knowledge and information for these videos comes from? That's actually my primary job, working as a consultant at DMS, where we are data-driven. We dig into the deep facts so that we can find the exceptions and create added value for you. If that's something that you're interested in, if you're looking for added value and a little extra edge, give us a call, check out the website, and let's see how we can make your ship exceptional. Thanks.